Hey guys, Calvin here. So, right, I have a what do you call this? A pie chart? No, that's a unit circle, right? So I have a unit circle here, and I've been wondering if we can apply it to real life. So I've just thought of this crazy idea that I'm going to measure the sun using a unit circle in trigonometry, right? In pre-calculus, of course, and what I learned in class, I apply it to real life, of course, right? And just to ingrain it into my mind. So let's see, right? So how do you do this? So as you can see here, right? That's a unit circle, right? You can see it has like shadows, and due to the sun, right? The sun up there, right? If the sun is down here and it's shining down here, right? Look, if the sun is up there, right? And the sun is shining down here, right? Shining down, and then this shadow, it just goes here, right? It shows you which measurement it is and how high the sun is, right? So let's say, for example, right, the let's say this one, right, the sun shines here. Currently is right here, but let's say it once here goes here later on, right? So that's like 60 degrees, pi over 3. And the coordinates are 1 over 2, square root of 3 over 2, right? Let me just jot them on my notebook real quick. So I have my notebook here, right? So the, what do you call it? So the sum formula for sine, right, is a plus b, right? Sine a plus b, which is just sine a cosine b plus sine b times cosine a, right? This is all times. That's times, right? And this formula is really important because it shows that we're trying to find the height of the sine, right? So let me try to explain sine a little bit for a second, right here. Let's say this is a right triangle, right? And let's say that this is sine, right? And this is cos, right? And this is tangent, right? Because sine over cos equals tangent, right? So it's just like a squared plus b squared equals c squared, right? And one the other will just like give you the other, right? And this is exactly the same as cos squared plus sine squared equals 1. And this is a fundamental trigonometric identity. So I got like a note here, right? And I got like I drew these right here. You see here, and I did note some things down right here, and this is the unit circle. So we're to draw like this, right? We're to draw like this. In a circle. 1, 2, plus, 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 negative, plus, negative, negative, negative. This one's negative and this one's positive, right? And they interchange between each other, and this 3, 2, 1, 1, 2, 3 over 2 over 2 over 2 over 2 over 2 over 2, and that's square root. So anything that's higher than 1, we square root it. You can see here, right? And this is, let's think of it as a graph, right? This is the y-axis, and this is the x-axis, and there's only a radius of 1. So that means anywhere you go here on the circle here, there's only a radius of 1. And you go here, that adds up to 1, right? So it's like 1, 0. It's like 0, 1. So I can see it, right? And what did I choose? I didn't remember choosing this one, right? I remember choosing this one, right? So it's like Sine A, right? So sine A. Remember, guys. So sine A, it doesn't really have anything to do with the sine, right? It doesn't mean just actually sine A and cosine B, right? Cosine A is the same as sine. Cosine A is the same as sine A because it's sine times A. Just think of it as multiplication. Yeah, basically, just think of it as multiplication, right? Sine A times cosine A. Cosine A times sine A, right? And A, let's see what A here is equal to. So this A and this is B, right? So A is equal to square root 3 over 2. And B is equal to 1/2, right? And let's see, right? So sine A. So sine A, what's sine of A? Sine cosine A? Sine A, right? Cosine B? Sine B, right? So sine is the y-axis, remember? Sine is the y-axis. And cosine is the x-axis. No, they literally just overcomplicate every stuff, but in simple terms, it's just the x-axis and y-axis. So here is let's see here. Square root 3 over 2 sine A, right? No, I messed that up. I messed that up. Let's see here. Let's write it over here, right? Sine A, right? So sine A, huh? 1/2 times cosine B. 1/2. No, I messed up. I messed up here, right? I messed up here. So, oh, I messed up, right? I messed up. I fell mistakes in my own. I fell mistakes in my own thing. It's actually square root 3 over 2 because sine A, sine times A. See, even though I have to use that, I'm tricked. So, like, because it confuses me a lot. So, sine times A was A and this is B. A and B, right? Plus, I knew something was immediately wrong when I tried it. So, B, right? It's B, it's 102 times square root. No, wait, hold on. Hold on a minute here. Something isn't right now. Can you spot something wrong? You know, it's a sine A plus B. And this is literally 30 degrees, right? Now, we can say that it's actually 15 degrees, I think. 15, right? So that's like 30, right? I'm gonna check the unit circle real quick. Okay, I got it. So I made a simple mistake here. So it was sine A plus B. No, it's actually sine A minus B, right? This minus. And sine A plus B, let's say if this was equal to double identity, right? Double identity. But let's say it wasn't equal to double identity, huh? That's weird. So like sine A times cosine B minus cosine A times sine B, right? And let's see, right? So we know that sine is equal to 1/2 here. But how do we prove that? How do we even prove that? Wait. If sine A is 1/2, right? Sine A is 3 over 2, right? Times cosine B, which is just 1/2, right? minus cosine A, right? Which is just square root 3 over 2, right? Times sine B, which is 1/2, right? Which is technically just 4 over square root 3 minus square root 3 over 4, right? Which is 0, right? Wait, that makes no sense. Huh. No, wait, I see her. Because we have 15 degrees. We were searching for 15 degrees all along. 15 degrees. Because on a unit circle, there's no 15 degrees. There's only 30 degrees. That's why we have to find the 15 degrees. So that's why I use sine A minus B, right? So that's like 45 minus 30. Sine 45 minus 30. So that's like 45 minus 30, right? This 45 and this 30. So that's like square root 2 over 2. So wait, sine A, right? 45 minus 30. So that's like A. And this is B. So sine A, right? Sine A is just... Sine A of 45 is square root 2 over 2, right? So that's correct. Times cosine B, right? Cosine B. So that's like 1/2. Right, 1/2. Is that right? No, that's sine though. That's like probably right, I guess. Whatever. 3 over 2, right? Minus cosine B. Cosine minus cosine A. Minus cosine A, so that's a square root over 2. Times sine B, right? Times 1/2. Immediately. 4 minus square root 6 over 4. So that's like 6 minus 2, right? Square root of 6 minus square root over 2 equals 4, right? So square root of 6 minus square root of 2, right? Which is just square root of 4 over 2, right? I mean 4, right? And square root of 4 is equal to 2, right? And 2 over 4, right? Was just 1/2. 2 divided by 2, 1/2, right? And that's how I derive this one from this one. So you can see that the sun's output energy is 0.50 at this point, which is just 50% of the sun's power. So that, how is you guys find out the sun's output energy using sine and cosine? Thank you. And let me know if I did anything wrong, because okay, I see now. So I did it wrong again. So it was not square root positive, but it was negative. So it was square root 6 2 minus parentheses square root 2 over 2. This is outside, so it doesn't matter. So this is 4, right? And this is 6 minus 4, which is 2, right? No, that's 4. That's 4, my bad. That's like 18. No, 16. No, wait, 16, wait. 16 divided by 4 divided by 4, which is 1 over 4, right? Right, 1 over 4, which is 2 times 1 over 4, which is just 2 over 4, which is just 1/2. And that, my friends, is how you find the sun's output energy. So guys, that was a tough one, but look, I myself made a lot of mistakes, and I gotta admit that was pretty hard. But with practice, with enough practice, you guys can do it yourself also. So let's go check on the sun right now, right? Let's see here. Let's see what's the thing up to now, right? Crap, I can't see none. Okay, so see that thing has moved a little bit. Now it's gone up to 60 degrees, pi over 3, and the coordinates here. And so I'll see you guys later, right? I'll see you next time I post another video.